These are the notes for the second part of section 8.2, special right triangles. This time we'll be talking about the properties of a 30, 60, 90 triangle. So this is very much related to the last video on 45, 45, 90 triangles. We just have a different one that also has a special relationship. So it says in a 30, 60, 90 triangle, the hypotenuse is twice the shorter leg, and the longer leg is square root of 3 times the shorter leg. So what we should be thinking using that same notation as before, we have x. We say the hypotenuse is twice the size of the shorter leg, so it's 2x. And the longer leg is the square root of 3 times x, so x square root of 3. A little review from before, the short leg has to be opposite the 30-degree angle. Remember, the shortest angle needs to be across from the shortest side, and 90 is the biggest angle, so it has to be across from the bigger side. So that's a little review from last, it was Unit 6, Triangle Properties. Whenever we try to break this down like we did with the 45, 45, 90, so we have 30, 60, 90. We call this x, or sorry, one triangle that we have is 1 square root of 3, and 2, we could verify that by the Pythagorean theorem. 1 squared plus the square root of 3 squared is equal to 2 squared. So that's a little way to check to see that we did it all right, and that's true. So 1 plus 3 is 4. So it is a right triangle. And this is the special property that we have. And we can compare it to any one of our problems. So for number 1, we have a 30, 60, 90 triangle. So we have y. So for number 1, we have y, 21, and x. So again, think about similar triangles. These triangles are similar by angle, angle. They have two angles that are the same, so they're similar by angle, angle, similarity. So if I want to solve for x, I just take one triangle, x and 21, and then I match it up with the other triangle. So x is the hypotenuse, so underneath x goes 2, and 21 goes with the short leg, which is just 1. So I cross multiply it, x is equal to 42. 2 times 21. So for number 1, I know x is equal to 42. And I can do that same thing when I solve for y. So when I solve for y, I can just use any two sides now. So I'll use y and 21. So what side corresponds with y? Well, that's the long leg, so it's going to be the square root of 3. And 21 still corresponds with 1. It's the short leg. So y is equal to 21 times the square root of 3. So all I need to do is write that same ratio for each one. So where the 30 degree is, remember that's 1 across from 30, square root of 3 across from 60, and 2 across from 10. So I have 1, 2, square root of 3. And then the actual triangle, what corresponds with those numbers? 1 corresponds with x, 2 corresponds with 10, and the square root of 3 corresponds with y. Just cross multiply them. 10 is equal to 2x divided by 2. X is 5. Change colors to black. 10 square root of 3 is equal to 2y divided by 2. This might be a little bit tricky, but we divide the numbers outside the square root, so we get y. 10 divided by 2 is 5 times the square root of 3. So these problems are very simple whenever you use that same strategy over and over and over again. So again, short leg, long leg, hypotenuse. So we have 1, 2, square root of 3. In our actual numbers, 8 goes underneath the square root of 3, y goes underneath 2, and x goes underneath 1. So whenever I solve for y, 2 times 8 is 16, is equal to the square root of 3 times y. You have to divide both sides by the square root of 3, and we get y is equal to 16 over the square root of 3. Now, a lot of people struggle with this. This isn't in simplest terms. We need to multiply it by the square root of 3 over the square root of 3, which would get us 16 square root of 3 over 3. I can solve for x, and it's actually going to be a similar type of solving. So 1 over x is equal to the square root of 3 over 8. 8 is equal to the square root of 3 times x. You divide by the square root of 3. And then we have to get rid of that square root of 3 in the denominator. So we multiply by the square root of 3 over the square root of 3. 8 square root of 3 over 3. That was x. So I'm going a little bit too fast. You can always slow down or rewind the video. But you should be able to see the 30, 60, 90 triangles in all of these. One thing that trips a lot of people up that is a 30, 60, 90 problem is any problem that has an equilateral triangle. So let me get out the correct tool. So this is an equilateral triangle. Every angle is 60 degrees. So remember, all three sides are congruent. And what you're asked to solve for in this problem is the height. So a lot of people look at this and they say, well, is it a 30, 60, 90 triangle? And it is. So we have 60, 90, and this is a 30-degree angle. So if I would make up some number for this, let's say if each side of the triangle was 8. Well, now that I would know that would be 8. And all I would do is I would have 8 and x. And remember, I have those sides. The short leg was 1. Long leg was square root of 3, and the hypotenuse was 2. So it would be over. So that's all we would do. 8 would be corresponding to 2. X would be corresponding to square root of 3. 8 square root of 3 is equal to 2x. Divide by 2. Numbers are on the outside. X is equal to 4 times the square root of 3. So I'd like you to try these last ones. Try 4, 5, and 6 on your own. All of these are 30, 60, 90 triangles. And please come to class prepared with any questions you might have.